Okay, guys, this is the Math 150 College Algebra Unit 4 practice test for Miss Metter's class. Number 1 says solve the system by graphing. Most of you probably would solve for y and do y equals mx plus b, but both of these equations are set up in standard form. So I'm going to use the intercept method to do this. So the x-intercept is the value of x when y is 0. So you're going to let y be 0. All right. So in the first equation, we'll call this 1 and 2. In the first equation, we have x plus y. So that's going to be x plus 0, which is just x, equals 3. So that's the x-intercept for the first equation. The y-intercept is the value of y when x is 0. So in that first equation, if you let x be 0, you have 0 plus y, so y equals 3. So we now know that the x-intercept is 3, so that's going to be here, and the y-intercept is 3, and you're just going to connect that with a line. And then second equation we have, if I'm looking for the x-intercept, I let y be 0, so x minus 0 is just x equals 1. And then on the second equation, if I let y be 0, let x be 0, because I'm looking for y. It's 0 minus y, so it's negative y equals 1. So you would have to divide both sides by negative 1 to get the y-intercept of negative 1. So in the second equation, we have an x-intercept of 1 and a y-intercept of negative 1. And we're going to connect the dots. And the point where the two cross looks like it's going to be at 2, 1. So that's the point where the two lines cross, and that's the solution. And when you have one solution to a system, that's called an independent system. Okay, the second, problem number 2 says solve the system by graphing. You'll notice the equation 1 is in y equals mx plus b form. So I'm going to use slope-intercept form to graph that one. So the slope is negative 1/2, and the y-intercept is 1. Y equals mx plus b. So we're going to plot the b first. B is where we begin. Now the y-intercept is 1. I don't know if you noticed, but on this graph it's graphing by 2's. The tick marks are 2's. So 1 would be right there. And then we're going to go down 1 over 2, so a rise of negative 1 means, so if that's at 1, we're going to go down 1 and over 1, 2. Oh, be careful, down 1 over 2, because that's 2. And it looks a little something like that. Since the second equation is in standard form, I'm going to use the intercept method again. So I'm going to find the x-intercept is the value of x when y is 0. So 4 times 0 is 0, so I'm left with 2x equals 32, and if I divide both sides by 2, I get an x-intercept of 16. And then the y-intercept is the value of y when x is 0. So if x is 0, in the second equation I have 4y plus 2 times 0, which is 0, equals 32. So when I divide both sides by 4, I get a y-intercept of 8. So my x-intercept was 16, which would be here. My y-intercept is 8, which would be here. And then what you're noticing, maybe, now it sort of looks like the two lines are going to cross, but because I did this by hand, I'm not sure. So these lines actually do not cross because they have the same slope. Because if I count down from this red line, if I go down 8, rise down 8 and over 16, that slope is negative 8 over 16, which is a slope of negative 1/2. So the second equation and the first equation are parallel lines. They have the same slope, so they never intersect, so there's no solution, and that's called an inconsistent system. All right, the next problem, problem number 3, says solve the system by substitution. And this one's set up nice for substitution because it's already got x equals. So we're going to take what x equals in the second equation and plug it into the first equation. So I have 5 times whatever x is, so stuff, so parentheses, plus 9y equals 41. And then instead of the x, I'm going to plug in what x equals, which is 19 minus 3y. All right, so I'm going to distribute and then combine like terms. Let's see, 5 times 19. I get 95. 5 times negative 3y is negative 15y plus 9y equals 41. I'm going to combine like terms right here. So I got 95 minus 6y. Negative 15 plus 9 is negative 6 equals 41. And then I'm going to subtract 95 from both sides. So 41 minus 95. I get negative 54. And then I'm going to divide both sides by negative 6, and I get a positive 9. So now we know what 9 is. I'm sorry, we know what y is. We got to find x. So I'm going to go back up here to my original equation that said x equals 19 minus 3 times whatever y is, and we just found y to be 9. So you can type that on your calculator if you'd like. 19 minus 3 times 9, and you get negative 8. So your ordered pair, the point where the two lines cross, is negative 8, positive 9, and that has one answer, so that's called an independent system. Question 4 says solve the system by substitution, and actually I'm just looking at these equations. They're both in y equals mx plus b form. So we can see the slope and the y-intercept of both lines right now, and what you should notice is that the slope is the same for both lines. So they're parallel. Lines that have the same slope are parallel lines. And they're not the same line because they have two different y-intercepts. So they're parallel and they're not the same line. So that's going to be no solution, and that's called inconsistent. Question 5 says solve the system by addition. Now I want you to be cautious right here. They're almost in standard form. The first equation is 4x minus 5y equals 13. That is in standard form. But the second equation, notice that they have the x second. So I'm going to rewrite that with negative 4x first and positive or plus 5y second. And now when you add vertically, you're going to notice that both the x and the y's cancel. And when both variables cancel, you have a special case. It's either no solution or infinitely many solutions. And when we add these two equations vertically, we get 28 on the right, and 0 does not equal 28, never does, never will. So that's going to be no solution and inconsistent. We also know that these lines are parallel if we were to graph them because there's no solution. All right, question 6 says Miss Suzuki invested $24,000 in 2 accounts, one yielding 7% interest and the other yielding 11% interest. If she received a total of $2,120 of interest at the end of the year, how much did she invest in each account? So the question, how much did she invest in each account, that tells us what our variables are, the unknowns. So our variables, we're just going to call x and y. How much she invests in each account, we don't know. Now what do we know? Since we have two unknowns, we have to have 2 equations. So I'm going to start with the 24,000. We know that however much she puts in the first account, which we'll call x, and however much she puts in the second account, we're going to call y, the total of that is $24,000. And then we're going to need another equation relating the interest. So 7% interest is going to be 0.07 times x, and 11% in the y account, so plus 0.11y. So this is going to be the amount of interest she made off the first account. This is the amount of interest off the second, and we know the total amount of interest was $21.20. So you have a system of equations, and I'm going to use elimination. So I'm just going to take this first equation and multiply the entire first equation by negative 0.07, and then my x's are going to cancel. So I'm going to rewrite my new equation 1 down here. So negative 0.07x minus 0.07y equals, let's do 24,000 times negative 0.07. and I get negative 1680. So I just did negative 0.07 times all of those. And so now when I add my second equation to my new first equation, the negative 0.07x plus 0.07x cancels. We have 0.11 minus 0.07, that's going to be 0.04 times y, and then 2120 minus 1680, and I get 440. So now to solve for y, I'm going to divide by 0.04 on both sides, and 440 divided by 0.04 is going to be $11,000. Now that's how much she's putting into the Y account, which for us, that's the 11% account. So we're going to have $11,000 in the 11% account. And since she invested a total of $24,000, we just can do 24,000 minus $11,000, and we get $13,000. And that's in the 7% account. All right. Question 7 says determine whether the given point is the solution set to the given system. So they give you a point, an x and a y, and we got to determine, does this point make both equations true? So all we're going to do is plug in x and y and see if we get a true statement or a false statement. So 7 times whatever x is minus whatever y is, does that equal negative 22? So x is negative 2. Y is 8. That's going to be negative 14 minus 8. That is negative 22. So that is a true statement. So the point works in the first equation, but we also have to check the second equation. So in the second equation, we have y. Well, we're plugging in y to be 8. Does that equal whatever we get when we square x and add 4? So x in this ordered pair is negative 2. Well, negative 2 squared is 4, and 4 plus 4 does equal 8. So yes, it makes both equations true. So it is a solution to the system. Okay, question 8 says solve the system algebraically, then graph both equations on the same coordinate system to support your solution. So algebraically means elimination or substitution. Well, I'm going to use substitution because I know what y equals x squared, and I'm going to plug that into the second equation where there was a y. So I have 9x minus whatever y was equals 20, and we know that y equals x squared. Now this is a quadratic equation, and I need to set this equal to 0 and factor. Since this is minus x squared, I want to move that to the right and that to the right. So when I move negative x squared to the right, I get positive x squared. When I move 9x to the right, I get minus 9x, and I already had positive or plus 20 over there. And then you're going to factor that. So we want to multiply to get a positive. Either they're both positive or they're both negative. The middle sign's negative, so they're both negative. We want to multiply to get 20 and add to get 9. So it's going to be minus 4 and minus 5. Negative 4 times negative 5 is 20. Negative 4 minus 5 is negative 9. Remember, when you bring them out of the parentheses, you change the signs. So I have two values of x. X could be 4, x could be 5. So now I'm going to plug that into my equation 1 for both cases. So y is going to be whatever x is squared. And if x is 4, 4 squared is 16. So we have the ordered pair 4, 16. And then if you let x be 5, we have y equals whatever x is squared from the first equation, and you plug 5 in, and you're going to get 25. So that ordered pair, that point where the two curves cross, is at 5, 25. Now your first graph, when you go to the graphing tool, that's an x squared, so that's a parabola. So you're going to click the parabola icon, and then 0, 0, it sits at the origin. And then we know two other points on this parabola, so I'm just going to, I would drag right 4 to 16. So 4, 16 would be like right here-ish, and it should draw the parabola for you. Trying to get it. Whoops. And so a real rough sketch because I can't draw. There's your parabola. And then your line, you could solve for y and do y equals mx plus b, but you already know 2 points on this line. You know the point 416 and 525. So click on your line on the graphing tool and click a point at 416. Let me go with a different color here. And then a point at 525. Okay, 525 is not on your thing. So let's find another, I'm just going to find the y-intercept real quick for that line. So the y-intercept is the value of y when x is 0. So in the second equation, I'm going to let x be 0. 9 times 0 is 0, and I have negative y equals 20. Divide both sides by negative 1, and you get y and it equals negative 20. So that's my y-intercept. And so then we know it crosses up here at 416 and 0, negative 20. And so the other crossing point would be up here off the charts. You can't see that on this graph. Okay, question number 9 says graph both equations to support your conclusions. Actually, it said solve. I'm going to solve using substitution. So y equals y here. So I'm going to take, I'm going to take what y equals here and plug it in right there. So square root of x is equal to 6x. Now to get rid of the square root, I'm going to square both sides. So I'm going to square the left side, and I'm going to square the right side. Square root and squares cancel, leaving me with x. 6x times a 6x is a 36x squared. So we have a quadratic, so I need to set it equal to 0. So I'm going to move this x over here, and that gives me 0 equals 36x squared minus x, because when I move something to the other side, to the opposite side, you do the opposite, so it's like subtracting x. What I notice here is both of these terms in this binomial have an x in them. So I'm going to factor out an x, and that leaves me with 36x minus 1. Factor means divide, so 36x squared divided by x is 36x, and negative x divided by x is negative 1. And we got that set equal to 0, so if a product equals 0, one of the factors or one of the terms are equal to 0, so x could be 0, or 36 minus x minus 1. Sorry, 36x minus 1 could be 0. So if I solve this for x over here, I'm going to add 1 to both sides and divide both sides by 36. And so I get two different x values. Now remember, we're finding points where the two lines cross, so you got to plug in your x back in to solve for y. So I'm going to plug it into my second equation because it's just 6 times x. So if x is 0, that's my first solution, I have 6 times 0, which is 0. So one of my points is 0, 0. That's one of my solutions. The other point, when I plug in 1 over 36 for x, whoops, got a 6 out front. Well, let's undo that. 6 times whatever x is. We said x could be 1 over 36 as well. And 6 times 1 over 36 is 1/6. So my second point is 1 over 36, comma, and y is going to be 1/6. So if you're looking at the graphs, if you took pre-cal, you should know that the square root function looks like this. So it's definitely not the middle graph. And then y equals 6x is a line with a slope of 6. This has a negative slope, and so that's the correct answer. Remember, you can use your graphing calculator and zoom standard, but I'm going to tell you, they zoomed in on this C graph where you could actually see where it crossed 2 times. If you zoom standard, you're not going to see that with the naked eye. Okay, question 10 says solve the system algebraically. First thing I notice is that we have a circle and a line. The first equation is a circle because you have an x squared plus a y squared, and it equals 9. So standard form of a circle is x minus h quantity squared plus y minus k quantity times quantity quantity squared equals the radius squared. So nothing is inside with x or y, so the center of our circle is going to be 0, 0. And the 9 is not the radius, the 9 is the radius squared. So if you take the square root of that, if you take the square root of that, the radius is going to be 3. So when I look at my graphs down here, the only circle that has a center at 0, 0 is this one. The other circles don't have a center at 0, 0. So that's the correct graph. Now, it says to solve algebraically, so I'm going to use substitution. If y is equal to x, then I'm going to put in the first equation, take the second equation and plug it into the first. So in the first equation, I have x squared plus whatever y is squared equals 9, and y is equal to x. So we have an x squared plus an x squared. That makes 2x squared equals 9. We're going to divide both sides by 2. So we get x squared equals 9 halves, and then to get rid of the square, we're going to take the square root of the left and the square root of the right. Square root and squares cancel. When you take the square root, you got to take into account the plus and the minus solution, plus or minus. The square root of 9 is 3, and the square root of 2 is not nice. So you just take the square of the top, square of the bottom. Now, you can't leave the square root of 2 in there, so we're going to rationalize the denominator. We're going to multiply top and bottom by square root of 2. And that gives us our answer, plus or minus 3 times radical 2 on top is 3 radical 2. And in the denominator, we have a square root of 2 times square root of 2, which is square root of 4, which is 2. Anytime you have a square root times itself, it gives you what's underneath. So now we have two x values. We're going to have two y values. But remember, y is equal to x. So my two ordered pairs are going to be easy. When x is positive 3 radical 2 over 2, so is y, because y equals x. And then separate with a comma your two ordered pairs, and then we have when x is negative 3 radical 2 over 2, y is also negative 3 radical 2 over 2. Okay, question 11 says solve. This question always seems to bother students because they don't like fractions, and we definitely don't like variables in our denominator. But if I were to stack these two equations on top of one another, so line them up, so I would have negative 4 over y, back it up, negative 4 over x minus a negative 4 over y, so that minus a negative becomes plus a positive 4 over y equals negative 8, 7. So that's my first equation, and I'm going to write my second equation underneath it. 3 over x plus negative 8 over y equals 11 sevenths. Now, I noticed that in my middle column here, 4 over y and negative 8 over y, if this 4 over y could become 8 over y, then I could add vertically and eliminate the y's. So I'm going to multiply this whole equation by 2 because I want this to become an 8 over y. But I have to distribute to everything in that equation. So I'm going to have a new equation 1. 2 times negative 4 is negative 8 over x. 2 times 4 is positive 8 over y. And don't forget, 2 times negative 8, negative 16 over 7. And then I'm just going to rewrite my second equation over here underneath it. And so we're going to add vertically, and 8 over y plus a negative 8 over y is going to cancel. Negative 8 over x plus 3 over x is going to be negative 5 over x. So you have common denominator, so you keep the denominator and add the numerators. And over here we have negative 16 over 7 plus 11 over 7. That's going to give us negative 5 over 7. I noticed right off that negative 5 is equal to negative 5, so then x must be 7. Okay, that's going to be one of my solutions. You could cross multiply and say, all right, x times negative 5 is negative 5x. Negative 5 times 7 is negative 35. And then divide both sides by negative 5, and you would get positive 7, which is what we already concluded. So once you know x, how do you find y? You have to plug it back into one of your first equations. So I'm going to plug this into, I'm just going to pick the second equation. So the second equation, I had 3 over x, which we found x to be 7, plus negative 8 over y equals 11 sevenths. I'm going to minus 3 sevenths on both sides. So I'm going to be left with negative 8 over y. And 11 sevenths minus 3 sevenths is 8 sevenths. And I'm going to cross multiply. So y times 8 is 8y. Negative 8 times 7 is negative 56. And when you divide both sides by 8, you get y equals negative 7. So my ordered pair there is going to be 7, comma, negative 7. Okay, number 12 says solve the problem using a system of equations in 2 variables. Find the 2 numbers whose sum is 22 and whose product is 117. Actually, easier than using a system. We're going to solve this by listing the factors of 117, because the product means you multiply to get 117. So let's do like a little factor tree. 1 times 117 gives you 117. All right, well, 117 can't be divided by 2. 117 divided by 3 is 39. Okay? Now I'm looking for a sum of 22. So I want the 2 numbers to multiply to give you 117 and a sum of 22. Well, right now the sum of 3 and 39 would be 42, so that's too big. So you're going to keep going, 117 divided by whatever. Well, I know that 39 is divisible by 13, so I did 117 divided by 13, and I got 9. So 13 times 9 gives you 117, and guess what? The sum of that is 22. So my 2 numbers are 9, comma, and 13. All right, number 13. Match the inequality with one of the graphs shown to the right. Well, mine are actually below because I copy and paste. First thing I notice in our inequality is it says y is greater. Y is greater. Greater is above. So if it's shading below, that's not going to be the graphs. So it's either going to be C or D. And your equation is in y equals mx plus b form. So the slope of our line, since there's no number out in front of x, there's a slope of 1. It's a positive slope. And so C has a positive slope, D has a negative slope, so the answer is C. And that's that. All right, question 14 says, match the inequality x plus y is greater than 1 with the graphs. Well, I noticed that it's just a greater than. There's no equal to on that, so it's not going to be a solid line. So we can mark out A and B. If you were to solve this inequality for y and put it in y equals mx plus b form, you would just have to move the x over here. So we're going to get y is greater than negative x plus 1. So our slope is negative 1, and our y-intercept is positive 1. And so if you look at the 2 remaining graphs, C has a negative slope, and D has a positive slope. So we don't want positive, we need a negative slope, so the answer is C. And greater than, y is greater than, so we're shading above, which is correct. Question 15 wants you to sketch your own graph. So if you're going to use, if you want to solve for y, all you got to do is move x to the other side. So we get y is greater than negative x plus 6. So your y-intercept is 6, so you go up to 6 and put a dot. The slope is negative 1. So that means that's your rise over your run. So you're going to rise down 1 and run right 1. So down 1, right 1 is right there. Make sure you make your line dotted. So I'm going to make mine. And then we also have to decide where we're going to shade, above or below. Well, if it's y is greater than, you shade above. I do want to remind you that if you have to multiply or divide by a negative with an inequality, remember to flip your inequality. Okay, question 16 says graph the inequality. This one's really easy because it's just y equals. So if you go up to the y-axis, you go to y equals 6, we should have a horizontal line going through there, and it's going to be a solid line because it's equal to, oops, try that again. It's picking up. It's being very sensitive today. There we go. Solid line, and then it's less than, less is below, so you would shade below. Okay, question 17 wants you to sketch the graph of the following nonlinear inequality. So I notice that it's an x squared, so that's a parabola, a quadratic equation. Y equals negative 6x squared. So it's going to be setting at the origin. So you click on your graphing utility. You want to click the parabola, and it's going to be set at the origin. Now, if you need you need another point. So if you just let x be 1, and well, first of all, if you let x be 0, y is going to be negative 6 times 0 squared. So the point 0, 0 is on your curve. And then if you let x equal 1, that's going to be negative 6 times 1 squared. 1 squared is 1 times negative 6 is negative 6. So 1, negative 6 is a point on your parabola. And then the graphing tool will graph the rest for you. You just need 2 points, I believe. Remember, on your graphing calculator, you can go to your y equals screen and type this in, and then go to second graph, and it'll give you a table of values, so if you want different x's or y's. Okay, number 18 wants you to graph, oh, time out. Time out. I'm not done with that last problem. I'm sorry. That was an inequality, so I should have been making solid and dotted lines and shading above or below. So back on 17, since there is no equal to, this would be dotted. That's terrible. Let's try this again. So that would be a dotted line or a dotted parabola. And then greater than, always find your vertex, and then greater than would be above the vertex, so you would be shading everything over here. Okay, there we go. Okay, question 18 wants you to sketch the graph of the solution set to the following system of inequalities. They give you both equations in y equals mx plus b form. So in your first inequality, y is greater than x minus 4. Your slope is 1 because that's the number out in front of x, and your b, your y-intercept, is negative 4. So we're going to go to negative 4, and then we're going to rise 1, run 1, because slope, if you want to make it a fraction where it's rise over run, you just put a 1 under it. So we're going to go up 1, over 1, up 1, over 1, up 1, over 1. Rise of 1, run of 1. Now, that is going to be a dotted line because there's no equal to on that. So there's my line. And then we're going to shade above that. So above that's going to be this direction, all right? But I'm going to wait and shade at the end because we're going to have some shading that overlaps. My second inequality was y is less than negative x minus 1. So this time the slope is negative 1 or negative 1 over 1, and the y-intercept is also negative 1. So I'm going to plot the y-intercept first, negative 1, and I'm going to rise down 1 and run 1. So down 1, right 1, down 1, right 1. And that's another dotted line because there's no equal to on that. And we're supposed to shade less than this one, which would be below this one. So if you're shading above the first one and less than the second one, that's going to be the area over here in between the two lines. Okay, number 19, we're going to graph the solution set of the following system of inequalities. I notice my first equation or inequality is a parabola because it's x squared. So, and it's x squared minus 4, so it's been shifted down 4 from the parent function. So you're going to click on the parabola on your graphing utility, and then if you need points for this, you can go to your y equals screen on your calculator, type in x squared minus 4. You can zoom standard look at the graph, but you can hit second graph to look at a table. So on our table of values, 0, -4 is a point, and then 1, -3 is a point. And it's equal to, so this is going to be a solid line. The parabola is going to be solid because of the equal to. And greater than would be above the vertex. So that's like up here. I don't want to shade it in yet, but it would be like up here in the middle of the parabola. My second inequality is x minus y is greater than or equal to -2. So I'm going to move x to the other side. And so I'm minusing x minus x. So I got -x minus 2. And I'm going to divide everything by -1. Make sure you flip your inequality because you divided by negative. So a -1 divided by -1 gives you a positive 1x. And this is going to be plus 2. So the slope is 1 or 1 over 1. And the b, the y-intercept, is 2. So I'm going to go up to the y-axis and got my point there, almost on it. And then we're going to rise 1, run 1, up 1, over 1, up 1, over 1, down 1, left 1. And it is a solid line because of the equal to on our inequality right there. There we go. And here, because we flipped the inequality, we don't look at the original. You don't look at the original to determine where you shade. You look at the y equals. So y has got to be less than or equal to that. So less than is below the red line. And so the two shadings would overlap in the middle because it's greater than on the parabola, which is above the vertex, and it's less than for the line, which is below the red line. Okay, last problem. You're given 4 inequalities, and so your first two, a lot of people don't notice that there's 2 there. It's x is greater than equal to 0, so that's a vertical line that goes through x equals 0. And we're going to shade greater than that, which would be to the right, okay? It's a solid line because of the equal to. My second inequality is y is greater than or equal to 0. That is the horizontal line, y equals 0. And greater than that would be above that. So right now we're shading above the horizontal line and to the right of the vertical line, which would be the first quadrant up here. My next 2 inequalities are both given in standard form, so I'm going to use the intercept method. I'm going to call this 1, 2, 3. That's horrible. My inequality 3, I'm going to use the x-intercept and the y-intercept to graph this because it's going to be the fastest way. So if I was looking for the x-intercept, remember that's the value of x when y is 0. So basically this is 0, right? So we're thinking of y as being 0. So that's going to give me 9x plus nothing. So 9x is less than or equal to 63. And divide by 9 and you get x equals 7. So that's the x-intercept on this graph. Now to find the y-intercept, that's the value of y when x is 0. So I'm going to let x be 0 this time. So 9 times 0 is 0 plus 7y equals 63. Divide by 7, you get y equals 9. So you just found the x and the y-intercept for inequality 3. So if I were to graph that, x is 7, which would be about here. Y is 9, the y-intercept. And then I'm going to connect the dots. And that is a less than, so I would be shading below that line. So right now, the overlapping of the shading is this triangular region right here. But I have one more inequality. So inequality 4, I'm going to use the x and y-intercepts again. So the x-intercept is the value of x when y is 0. So in the last inequality, if I let y be 0, I have 9 times 0, which is just 0, so equal to 63. And I'm going to divide both sides by 7. So I get an x-intercept of 9. And then to find the y-intercept, I let x be 0. So I'm left with 9y equals 63. And I'm going to divide by 9. And I get a y-intercept of 7. So this last graph, the x-intercept was 9. The y-intercept was 7. And connect the dots. And on this one, it is also a less than. So less would be below that blue line, which means the shaded area is right here, that little quadrilateral space. All right, that's all for the Unit 4 practice tests. Study hard and good luck.